This is a learning module for section 8.3 of the Matter and Interactions textbook. And here we discuss the consequence of temperature on the energy states of a sample of atoms. Okay, so first point to make, which we haven't yet discussed, is that while an atom or molecule can absorb a photon and transition between energy levels, or emit a photon and transition between energy levels, it can also gain energy by collisions with other microscopic objects. So suppose I have an atom and I have a free electron which collides with it, which has some kinetic energy. Then if this electron collides with the atom and a collision takes place, what can happen, if this is the initial energy of the atom, then the final energy of the atom can be different, and the electron will have a smaller or a different kinetic energy. So the atom can absorb the energy, the kinetic energy from the electron that matches one of its energy levels. So for instance, if this atom is initially in the ground state and then this electron collides with it and the atom ends up in the first excited state, then the kinetic energy of this electron, if we apply the momentum principle, is equal to its initial kinetic energy minus what it lost, which is the energy between E1 and E2. Okay. So now the effective temperature on a sample is that previously when we were discussing that in a sample of many atoms, that all the atoms are in their ground state energies, that's effectively a low temperature phenomenon. So for low temperatures, all of the atoms in a sample will be situated in the ground state of possible energy levels. If, however, we raise the temperature, by raising the temperature, we raise some of these atoms, we will add energy to them, and they will become excited. And so we will have some of the atoms, which are still in the ground state, but others will transition to higher energy levels. And in general, the probability of being in an energy level depends on the energy of that level. So the higher the energy, the less likely you are to have an atom at that energy level. So in general, most of the atoms will be at the ground state. Some of them will be in the first excited state. Fewer will be in the second excited state, and even fewer will be in the third excited state, etc. But nonetheless, there is some chance or likelihood that there's a population of atoms that are excited. And so in this case, we end up with spontaneous transitions between energy levels and photons coming out as a result. Okay, so that's basically the point of this section, which is that at low temperatures, all the atoms are in the ground state. At high temperatures, some of the atoms leak out into excited energy levels.